Right then, so question 6, we've got the equation of the line L1, which is y equals 3x minus 2, and the equation of the line L2, which is 3y minus 9x plus 5 equals 0. It says show that these two lines are parallel. So have a quick go at this one, see what you can come up with, and I'll come back with a solution in a second. Okay, so bit of an interesting question really. They've given us the equations of two straight lines. L1, we can think of that as the first line, and L2 the second line. And they're in different formats, aren't they? They look different. They're set out slightly differently. So let's introduce some stuff that we should know already, and that is there is a form that you can write straight line equations in, and we know it as y equals mx plus c, and the gradient is this number or this value that sits in front of the x. Alright, and they put the letter m there to represent that value. The c on the end represents where that line crosses the y-axis, so we call it the y-intercept. And as we are trying to show that the two lines are parallel, it might be useful to think about, here are two parallel lines. What is it that makes them parallel? Well, it's the gradient. They've got the same steepness, the same gradient. That's what makes the lines parallel. They are the same steepness, the same gradient. So we've got to show that these two lines have the same gradient, basically. If we look at the first one, L1, it's already in the form that we've got here, y equals mx plus c. So we've got y equals mx plus c. So the m is actually the 3 in front of the x. That's the gradient. All right, so we can say the gradient of L1 is 3. So we kind of know that the gradient of L2 must also be 3, because we've got to show that the two lines are parallel. So what are we going to do with this equation for us to sort of be able to show that the gradient is 3? Well, let's try and get it into the format of y equals mx plus c. So let's start with this equation. I want to make y the subject, and that means that I need to get it as y equals. In the first equation, y is already the subject because it's on its own. So how are we going to do that for the second one? So let's have a look. We need to get the y on its own. So I actually want to get rid of the minus 9x and the plus 5 by moving them to the other side of the equation. When they move to the other side of the equation, they're going to become the opposite, the inverse. So it's going to become minus 9x becomes plus 9x, and the plus 5 will become a minus 5, and it will look like this. Okay, so the first part is me moving across the 9x, the minus 9x become plus 9x, and the plus 5 become minus 5. That's the top line. And then I've got 3y, which would be left. I don't want 3y, I just want 1y. So I have to divide everything by 3. And if I divide everything by 3, then I get y equals 3x minus 5 divided by 3. Okay? Because I don't really know what 5 divided by 3 is. I could work it out, I suppose, but I don't really need to know that. So I'm just going to leave it as 5 over 3, which is perfectly acceptable to do. So we can see here, now we have the gradient. Again, we've just got a 3 in front of the x. So we can say that the gradient is 3 for L2 as well. And it's just good practice to write some sort of conclusion for a show that. So I'm just going to write down, therefore they are both parallel as they have the same gradients. Okay, and that's only worth 2 marks. So all the work was for rearranging this second equation here that we had. The mark scheme kind of reflects that. It's just saying that you get the first mark for a method that you're starting to try and compare the second line with the first one. You're trying to get it into a format so you can compare them, and the most common way is to do what we did by trying to rearrange it to get y equals. So if you start down that road, you'll start picking up a mark, and then also dividing by 3. It says this mark is given for comparing the two equations and by deducing that the gradients of the two lines are the same. So it's by getting your final answer here and noticing that you have the gradient 3 here and stating it. Okay, stating that the gradient is 3 for both lines. How did students do on this question? Well, you can see there's only 2 marks available, over a third got nothing. So people didn't really know what they were doing. A third of people didn't know how to start this one off, and only 53% got all the marks on that one. So I hope that was useful, and that gives you some idea of how to do that if it comes up again in the future.